Hey guys, I apologize that I am not there today. Please overlook my scratchy voice, and also if I start coughing, I apologize in advance. Um, Today's problem of the day or the warm up is when money is invested with compound interest, the value of the investment over time is modeled by initial investment times 1 plus the decimal interest rate raised to time. And that is the formula that we have been using the last couple of days, or I should say on Monday and Wednesday. So your problem says if 1,000 is invested at 2% interest for 2.5 years, how much will it be worth at the end of that time? So take a minute and write your equation and then also solve it. All right, so you should have found that P is 1,000. All right, and 2% is your R, but remember we change it from percent to a decimal, 0.02, and then 2.5 is your T. All right, so when we write our equation, you should have got A equals 1,000 times 1 plus 0.02 raised to the 2.5. All right, and so that is, I think I have it calculated right, 1,050.75. Yes, hopefully you all got that. All right. On this lesson, you're going to see it looks a little different than some of the other lessons we used, and that's because it is from something that I used at a previous school. Um, so it looks a little bit different. For instance, this kind of gives you the lesson focus in terms of the standards, the math practices, and then your objective and that sort of thing. It also tells you some vocabulary. And you guys have heard the word asymptote. I mentioned it a little bit when we were doing functions. This is exponential functions, and today is mostly about exponential growth. Um, so this unit is all about exponentials. And then remember that when we come back after Christmas break, we'll start quadratics. All right. Now, let me actually just clear the screen so I can start over. Apologies for that. An exponential function can be expressed in the form of f of x equals ab raised to the x, where a and b are real numbers with a not equal to 0. Now, first, let's talk about that. The reason a cannot equal 0 is because anything times 0 is 0. So it would just be f of x equals 0. And that would not be an exponential function. It would be a linear function. Okay. Um, it would actually be y equals 0 because f of x is just function notation, which is the same thing as y equals. And b cannot equal 1. Okay. And that is because 1 raised to any power is still just going to be 1. So there again, regardless of what your a is, it would just be f of x equals a number, and that would be linear instead of an exponential. I hope that makes sense. If not, please put a star by that, and we'll talk about it more tomorrow when I'm there. The parameter a is the value of f of x when x equals 0, and also the y-intercept of the graph of f. The parameter of b is the base of the exponential function. And if a is greater than 0 and b is greater than 1, then again, the function is referred to as an exponential growth function. Now, some of you may have questions about could those be a be less than 0 and b be less than 0, and you will see that when we start talking about decay. All right, so again, I'm just going to rewrite f of x equals ab to the x. A is the same thing as your 0 term. And if you remember from when we did functions, that is your y-intercept. All right. And b is going to be your base, and it's also called your ratio. In other words, what are you multiplying each time? If you remember when we did that one with the table, what are you multiplying by? All right. Base or ratio means that you're multiplying. I'm hoping that's making sense so far. All right, on the next piece, it says consider the exponential function f of x equals 2 raised to the x. Now, with this one, notice that there's no a there. It is understood to be f of x equals 1 times 2 raised to the x. Okay, your a is understood to be 1. All right, understood to be 1. If there is no a in front of your ratio, it's understood to be 1. All right, they got the table started for us, so they plugged in -3 and they got 1 over 2/3, which means that your coordinate point is -3, that's your x value, and 1 over 8 is your y value, because they did 2 to the third, which is 8. All right, and then on the next one, if we continue to fill those in, then we get -2 and 1/4, because 2 squared is a 4. All right, and then if I continue going down, then I get -1 comma 1/2, and then they filled in the next couple for us. And then if we do 2 squared, and then that means we've got 2 comma 4, and then 2 to the third is, oh, apologies, 3 comma 8. Apologies, I done something, and I'm not sure where it went. There it is. I was making sure I was still recording. Sorry about that. All right, so the next one is 3 comma 8. And then the last one, 2 to the fourth, we get 4 comma 16. All right, and if you notice, it labeled a couple of the points for us. All right, we got 0, -1, we got 1, 2, um, we got 2 comma 4, because this is going up by fives on your excuse me, on your Y's, that is going up by fives. So 2, 5, sorry, 2, 4, and then 3, 8, and then 4, 16. But they're not good intersecting points as you're going along, because of the way that they have the graph. All right. So the x value chosen in the table are integers. However, based on what you have previously learned, exponential functions are defined for all rational number inputs. Okay, remember that rational numbers includes your decimals or fractions. All right. Exponential functions are also defined for inputs that are irrational. And irrational, remember those were the one were like pi and non-perfect square roots, non-perfect cube roots, all those types of things. All right, and I'll write that as well. And also non-terminating / non-repeating decimals. All right. Now, B says, suppose x equals 4 1/2. What is the value of 4 1/2? Notice that 4.5 is in the parentheses, and that means you're using it for x. So you just type that into your equation. All right, so we're going to do 1 times 2, and then do your caret key, okay? And you're going to put 4.5, and you get 22.627417. So we're just going to round it to 2 decimal places. Okay, so we're going to say approximately 22 point, let's say 63. All right, because the 7 rounds the 2 up. All right. On the next one, it says if the domain of f is restricted to only integer values, describe the graph of f. Now, if you remember, integer values are your negatives, 0, and your positives, right? And those are whole numbers, negative, 0, and positive whole numbers. No decimals, fractions, anything like that. So in that case, it would be discrete. All right, and remember that discrete graph is only dots. It would not be connected. All right. On D, it says explain why the domain of f must include all rational and irrational values of x to obtain the smooth curve shown in the graph. So it must include all real numbers, which are rational and irrational numbers. To be continuous. And remember that a continuous graph means that the graph is connected. And hopefully you'll remember that I said discrete, D is D in discrete, D in dots, and then continuous, it has the CON for continuous and CON for connected. That's how I've always remembered it. You may come up with a different way to remember it. All right, pause it if you need to. I'm going to keep moving. And again, apologies. I left some of the notes on and didn't realize it. The graphs of 3 exponential growth functions are shown. So you've got f of x equals 2 raised to the x. You've got g of x equals 3 raised to the x. And you've got f of x equals 4 raised to the x. Now, one thing that you will notice here is there are no x-intercepts. It looks like it's touching the x-axis, but this one, all 3 of these, the graphs are approaching the x-axis, but never touching it. Okay? And that's because they have an asymptote of y equals 0. That is an imaginary line, which is why it's an equation, y equals 0, showing where the graph is going to approach but never touch. That's what asymptote is. All right? Now, you can know that from looking at the equations. If the equations do not have a constant at the end, it's understood to be plus 0. If it had a number out there at the end, then that would be its asymptote. Like if it said plus 1, then the asymptote would be y equals 1, which would mean the graph would approach where y equals 1, but it would never actually touch it. Now, if you look at this, what is the y-intercept for each of the graphs? Do any of the graphs have an x-intercept? Explain. We just talked about the x-intercept, okay? And then the y-intercept for all three is 1, okay? It is 1. And the reason why, okay, because anything raised to the 0 power, you should remember this from the last unit when we did exponents, equals 1. So 2 to the 0 power is 1, 3 to the 0 power is 1, 4 to the 0 power is 1. So all of those have a y-intercept of 1. All right, so 0, 1 is the y-intercept. All right, the next thing says examine the graphs of the exponential growth functions f of x, g of x, and h of x. What appears to be true about the domain and range values of these three exponential growth functions? Now, we've talked about domain um, in a couple of units, and we've talked about range. And remember, we talked about them in terms of set notation. We talked about interval notation. We talked about inequality notation. And remember, set notation we only used when it was discrete, which means individual dots. These are continuous, so we're going to use interval and inequality notation. Now, remember that domain deals with your x values. Remember when we learned Dixie loves Roy D? Domain is your x values. And so if it has arrows on the end, then that means it's going to go from negative infinity to positive infinity. This is your interval notation. All right. And then your inequality notation is negative infinity is, sorry, not a comma, apologies there, is less than x is less than infinity. This is your inequality notation. All right. We could also say all real numbers. Remember, we could also say all real numbers. And that's your symbol for all real numbers. Now, for range, remember that range is your y values. All right, and for this one, since your range is going to approach 0 but not actually touch it, 0 would not be included, so it would get a parentheses, not a bracket. So 0 comma infinity, because it goes up forever, and that would be 0 is less than y is less than infinity. And again, it doesn't get an equal to for 0 because it's not actually touching it. All right? And it would not get all real numbers because it does not go below 0. Hopefully this is making sense and coming back to you from when we did it before. Pause it if you need to. I'm going to go on. All right, so again, we have those same graphs to answer C, D, and E. All right, it says for each function, what happens to the value of the function as the value of x increases without bound? Now, excuse me, if you remember from when we did functions, increases without bound, oh, let me hit my pen. means that you are doing end behavior, but it is a specific one. If it is increasing, if the values of x is increasing without bound, that is headed toward positive infinity. And so that is as x is approaching positive infinity, what is your y approaching? And if you look, all three of those are going up. So y is also approaching positive infinity. And this is what it's looking for. It's just what's in the green or underlined in green. Because it tells you that x is approaching infinity when it says the value of x increases without bound. All right, the next one says what happens to the value of each function as the value of x decreases without bound. So again, it's talking about end behavior. But since it's decreasing, that means x is headed toward negative infinity. What is your y value approaching? And you'll notice that it is approaching 0. Okay? It's not going to touch it, but it's going to approach it. Now, the next one says, what is the value of the base for each of the functions? And remember that the base of each of the functions is what your variable is um, raised to, or sorry, which number has the exponent. Okay, and so for f of x, your base is 2. For g of x, your base is 3, and for h of x, your base is 4. Now, remember that base means ratio. All right, and then the next piece says for which value of b does the function increase most rapidly? In other words, which one is going up the fastest? And that is obviously going to be when it's multiplying by 4 versus by 3 and 2. All right, you can also see that because h of x is much closer to the y-axis than f of x or g of x. As it's moving up much quicker, and it is drawing closer to the y-axis than the other two. I really hope all this is making sense, but if it is not, please put stars on it so I can answer questions when I'm back in the classroom. Pause it if you need to. I'm going to keep going. All right. I'm just going to leave these answers on there. We just talked about this a little bit ago. The asymptote is a line that a graph gets closer to as the value of x increases or decreases without bound, but it never actually touches it. Okay? And I apologize. I wrote the wrong variable there. That should say y equals. Y equals is the asymptote. All right, and then a real world situation that could be modeled by an exponential growth function is investing money. You guys, when you're investing money, it could go up or down very quickly. I don't know if any of your parents have money in stocks, but they would definitely know what we're talking about there. All right, pause it if you need to. I'm going to keep going. Apologies again that I had answers in there. So previously you learned that the graph of y equals a times f of x was described as a vertical stretch or a vertical compression of the graph of y equals f of x. We learned that back when we did functions. We talked about stretch versus shrink or compression. You can use what you know about transformations of functions to graph exponential growth functions of the form g of x equals ab to the x. Um, we might not have talked a whole lot about stretching and shrinking. We'll talk more about it when we do the last part of Unit 4, where we compare linear, exponential, and quadratics. I will go into, um, we will basically recap functions and transformations of functions in that unit, because I want to make sure that you have all three at that point to look at. Okay. So for this one, it says the graph of f of x equals 2 to the x is shown. Consider the function g of x equals 3 times 2 raised to the x. Now, that means that 3 is your zero term. Your a, remember, is your zero term or your y-intercept. So instead of your y-intercept being 1, it would be 3 because 2 to the 0 is 1, and then 3 times 1 is 3. All right, so that answers this question A. What is the y-intercept of the graph of f? It would be 0, comma 1, okay, because 2 to the 0 is 1. But then for G, that would be 0, comma 3. All right. It says, what is the domain of F? What is the domain of G? These are actually both going to be the same. Even though your y-intercept changes, the domain is going to be the same. Negative infinity to positive infinity, because there's arrows on each side. Remember, that's interval, and inequality is negative infinity is less than x is less than infinity. All right? Or also remember, you could actually say all real numbers on this one. Now, the range will be different. The range will be different. The range of f is going to be from 0 to infinity, or 0 is less than y is less than infinity. And the range of g is going to be 3 to infinity, or 3 is less than y is less than infinity. Because it's going to be from your a up if it is going up from left to right. Now, it does say to use set builder notation as well. So I'm going to do those over here to the side. So for F, Y such that 0 is less than y is less than infinity. Okay. Or you could just say y is greater than 0. All right. That's for F. But for G, remember it would be different. The range would be y such that 3 is less than y is less than infinity. Or, oh, can't draw my squigglies today. Y such that y is greater than 3. Now, in terms of the variables that we use, remember that we are looking at decimals and fractions and all that. So it would be using real numbers, but it would be real numbers specifically that y is greater than 3. So you could say real numbers. Um, I'm trying to think of how you word it. Apologies, because my head is not clear this morning. um, I'll have to think on that one and I'll let you know tomorrow because I am forgetting how I write it. So I'll come back to that. All right. So put a star on C and we'll talk about it tomorrow. D says as X increases without bound, what happens to the graph of F? Remember that again, it's talking about end behavior. Okay. It's talking about end behavior. So I'm going to put EB. So as X increases without bound, what happens to the graph of X? So as X approaches positive infinity, because it says increases, the graph of X, Y is approaching positive infinity. All right. And what happens to the graph of G of X as it increases without bound? Well, they're both the same. Okay. They're both going to be the same. All right. And then for that last one, as X decreases without bound, what happens to the graph of F and the graph of G as X decreases without bound? Again, it's talking about end behavior, but this time it's X approaches negative infinity. Y is approaching 0 for F. And for G, that end behavior is going to be as X is approaching negative infinity, Y is approaching 3. Apologies, I just totally messed that up. I really am feeling cruddy today. I'm so sorry. Um, Even though it is going to cross at 3, it is still going to have a asymptote of 0 because there's no plus or minus there. So they will both be the same. I apologize there. And the range is also going to be the same. I am so sorry. Not even thinking. Some of you were probably already questioning it because y'all are so smart. There's an asymptote of 0, okay? So that means that's what they're approaching. So the range is 0 to infinity. Um, the let me change that to both. And the end behaviors are going to be the same. Again, I am so sorry. I truly am not feeling well this morning. And that is why we use erasers, people, is because Miss Delay makes mistakes. Pause it if you need to. I'm going to keep going. All right. Of the key characteristics discussed in parts A through E, what is the only characteristics of the graph of f of x equals 2 to x that is different for the graph of g of x equals 3 times 2 to the x? Um, and that is the y-intercept. All right. That was the only thing that was different. That was the only characteristic of the graph of f of x and g of x that was different. Excuse me. All right, the next one says, how do you know the graphs of f of x equals 2 to the x and g of x equals 3 times 2 to the x never cross the x-axis and x decreases without bounds? This one is actually one that you just can try, okay? So this is what I'm going to put. You can substitute any negative value for x and the y value will never be exactly 0. Now, I do want to warn you that if you put a really large negative number in there, your calculator is going to say 0, but it is because it is rounding. Remember that your calculator only does so many digits and then it rounds the last digit. So if you end up with, let me see if I can think of one. Hold on one second. If I do 3 times 2 raised to the, let's say, um, negative 11. Let's see what that is. It gives you 0.001. Okay, so it's not 0 because it's got all those numbers after the two zeros. 3 times 2 raised to the, let's say, negative 25. I think I did something wrong there. Okay, so if you do 3 times 2 to the negative 25, it gives you scientific notation and it has a negative exponent, which means you're going to have that many zeros in front of your um, your 8.94. Okay, so it says 8.94 and then some other numbers, e to the negative 8. Um, it's going to keep putting zeros in front, okay? Some calculators, though, will eventually just say 0. It won't give you like, let me see if my calculator does it. 3 times 2 raised to the negative 100, for instance. No, I'm using a different calculator than I normally do at school. It will continue to give me scientific notation. But some calculators would just round it to 0. All right, but it actually is not 0. It's just got lots of zeros there, and so that's why. All right, but you could substitute any negative value for x, and the y value will never be exactly 0. So it will never exactly touch 0. It's just going to approach it very quickly. All right. Um, Pause it if you need to. I'm going to keep going. All right, this is modeling exponential growth. It's a real world problem. Okay. It says exponential growth functions can be used to model situations represented by an initial amount A and growth rates. And these are what we did on Monday and Wednesday. So in these situations, the base is replaced by the growth factor, 1 plus R, and the exponential growth model becomes f of x equals a times 1 plus r raised to the x. In other words, it's becoming simple or compounded interest, okay, depending on what the formula says. All right, so a new investment account is opened with $4,000 at the interest rate shown. Okay, so the 4,000 is your P, okay, or in this case, your A. All right, at the interest rate shown. If no additional money is invested, what will be the value of the investment after 5 years? Now, 5 years is your t in or your x in this equation. Okay? So if we write this equation, we're going to have f of x equals 4,000 times 1 plus, remember 4.5 is 0.045, all right, raised to the fifth power, okay? Remember that your rate, again, you convert it to a decimal and you move it 2 places to the left. All right? Now it says write the exponential growth function that models the situation. We did that in orange. Okay, I'm just going to rewrite it over here. And I'm going to go ahead and add that in the parentheses. So 1.045 raised to the 5. All right. What does the value variable x represent in this situation? That is time. And in this specific situation, it is years. All right. And then it says find the value in 5 years. And when you do that, you get $4,984.73. Let me make sure I calculated that correctly before. Yes, the 7 rounds to 2 up. All right. It says, what would f of 5 minus f of 0 represent in this situation? What is the value of f of 5 minus f of 0? Now, if you subtract 4984.73, that's f of 5, minus f of 0, which is the original 4,000, you get $984.73. And that represents the interest earned. All right, that's what that is. That is your interest earned. All right. Now, the growth rate, remember that is 4.5, which equals 4.5%, which equals 0.045. And remember the growth factor is what you found in the parentheses. That is the 1 plus 0.045, which is 1.045. That is your growth factor. All right. Is it possible for the value of the investment in task 4 to at least double in 10 years? Explain. Well, if you plug in 10, you will see that it does not double. Okay. 4,000 raised to the 1. Sorry, times 1.045 raised to the 10 is going to give you 6,211. Let me make sure I rounded it correctly. $88. All right, and that is not doubled. So doubling your years does not mean you're doubling the amount. This video has gotten a little long, so I'm going to stop right here. We'll finish up the last little bit tomorrow. Um, Again, if you have questions, make sure that you have them starred on your paper.